Okay, so we want to be able to add and subtract algebraic expressions today. And ultimately, what we want to do here is to simplify these algebraic expressions. And how do we do that? Well, we've got some new terms here, which is like terms and non-like terms. So these are the examples. Looking at the terms here, 5e and 6e are like terms, whilst 5x and 5y are not like terms. X and 13x are like terms. On the other hand, 12xy and 21x are not like terms. 2bc and 4cb are like terms. On the other hand, 15abc and 4bcd are not like terms. The same thing, 3g squared and 45g squared are like terms, but 16g and 45g squared are not like terms. Anyone who could define for us what like terms are in simple words? What's the same? What's different? Like terms are terms that have the same pronumerals. That's right. So they need to have the same pronumerals. So x and y on the first example there, they're different and therefore they are not like terms, okay? Even if they've got the same coefficient, even if the coefficient of both would be 5, right? It doesn't matter, they're not like terms, okay? So when we look at like terms, we just look at the letters, right? But if we look at the last example there, we've got 16g and 45g squared, right? They are not like terms, even though they've got the same pronumerals, because with those pronumerals, we need to have their powers or their indices, or we call exponents. They need to have exactly the same index, okay? So when you have 6g and 45g squared, they are not like terms, even if you've got, for example, 5xy squared and 2x squared y, right? They've got exactly the same pronumerals, but if you have your coefficient or your index for x, the index of x is 1, the index of x here is squared, and on this one, the index of y is 2, whilst this one is 1. So they need to have exactly the same pronumerals with exact numbers or indices, okay? The other thing that we need to also emphasize would be the order of these letters would not matter, okay? So for example, when you have 2bc, if you have there 4cb, bc and cb would be just the same, because we've got our commutative property, all right, of multiplication. So just like when you have 5 times 3, that's the same as 3 times 5, okay? So now we've got some examples and non-examples of like terms. Why do we want them? Because then from there, we would be able to simplify these algebraic expressions by adding and subtracting, or subtracting their coefficients, okay? So for example, we've got the 6b plus 4b. We just look at the coefficients and we perform the operation. So if it's addition, then we just add 6 and 4, we get 10b, okay? When we have 12y plus 3y minus 5y, we simply look at the coefficients, right? So that's 12 plus 3 minus 5, right? We've got 10y, right? When we've got 4t minus 3t, that means it's 4 minus 3. What's 4 minus 3 equal to? It's 1t. And again, when we write the coefficients, when the coefficient is 1, we simply write t. Okay, why do we do that? It's because 1 times any number would give us that number. 1 times 7 would give us 7. 1 times 100 would give us 100. 1 times 1,000,001 would give us 1,000,001. So when you've got there a 1 as the number that you multiply to t, what that would be equal to is t. 1 times t would always be equal to t. Okay, let's probably do these examples here. When we've got 4g plus 6g, we look at the coefficients. We have 4 and 6. When we add 4 and 6, we get 10. What's our pronumeral? It's g, and therefore we simply write 10g. Okay. When we have question B, 11ab minus ab. So that's an invisible coefficient. For the second one, there's an invisible 1ab there. So that's 11 minus 1, which gives us 10ab. So when we add 6 and 5, we get 11. And then that's when you can actually just simply write AD instead of DA, because again, just like the previous lesson, we said we want these letters in order, specifically in alphabetical order. Okay, let's have a look at question D. It says 4t plus 7t minus 5. So looking at the terms here, we've got 3 terms. The first 2 terms are like terms, and therefore we can add 4 and 7. We get 11t. And then what do we do to the minus 5? That's it. We just plug it in. We just put minus 5. Okay. And let's have that last one there. 8x plus 3y. Can we simplify it further? No, they are not like terms. One is x, one is y, right? And therefore, that's already simplified. Okay, I'll let you do your work. If you've got any questions, message me. All right.